And welcome everybody. Welcome again to the third episode of the GitOps webinar by Bespinian and Vision. Today is Thursday, July the 8th, 2021. It's 4 p.m. in Central Europe Standard Daylight Time. And my name is Adrian Kosmaczewski. I'm Developer Relations at Vision. And it's my privilege to introduce to you the two stars of tonight's episode, the third episode of this GitOps webinar series, Lena Fuhrimann and Dr. Mathis Kretz from bespinian. And of course, the Star Wars fans amongst you, you are already aware of what's going on with the logo and the name of their company. Previously in this series, if you haven't watched them, we had an introduction to Git to know exactly what it is, how to use it properly, and all of the important features that it brings to the developer workflow. Then in the second episode, we learned about infrastructure as code, and we've seen many different use cases and interesting demos. So today, the third episode is actually the GitOps thing. So we're going to learn what it is, how to use it, some best practices, some tools, and some ideas of how it can bring benefits to your developer workflow. So without further ado, here is Lena and Mathis from bespinian. I'm going to stop sharing and the screen is yours.
Thank you very much, Adrian. I'm gonna share the screen on my side. So can everybody see what I'm sharing?
Yes, perfectly well.
Thank you. Right, so welcome friends and future friends to this third and last episode of our GitOps webinar trilogy. Today, we will show you how you can combine Git, which we introduced in episode 1, with infrastructure as code, which we introduced in episode 2. The combinations of these two worlds will lead us to GitOps, where we will show you concepts and technologies which enable you to operate your infrastructure and applications entirely using Git repositories. We will proceed in 2 steps. First, showing you how to do GitOps with applications, and then how to extend the same principles to your infrastructure stack. Before we dive into how we perform GitOps for applications and infrastructure, let's first have a look at the general ideas and assumptions behind GitOps. Let's first look at what problem GitOps aims to solve. Applications made up of many microservices are hard to keep track of when deployed in many different environments. Environments can easily start to diverge and become snowflakes, and GitOps proposes the following solution to this problem. We represent the desired state of our applications and environments declaratively as code, and version this declarative representation in Git. The declarative representation in Git is read by an automatic process, which applies it to the target environment based on certain events. The most important event is when a change happens in the Git repository holding the desired state. However, depending on how strict we want our setup to be, the automatic process could also react to manual changes to the applications or the environment's infrastructure. In this strict setting, the manual process would override such changes with the desired state from Git. This means that changes to your applications and infrastructure are done exclusively through operations in Git. This in turn means that all of the Git goodness that we showed you in episode 1 of this webinar series can now help you with those changes. You automatically get a history of all the changes and who they were performed by. You can pass new changes to team members for a review. You can implement change approval processing using merge requests. And furthermore, your environments automatically stay documented without any extra effort. So in this first part, we want to focus on how you can do GitOps for your applications. Maybe you're part of a team which is building a complex microservice-based application with another team providing the infrastructure platform to you. Then this first part will already contain all of the concepts you need. On the other hand, maybe your team also provisions its own infrastructure. Then the second part on declarative infrastructure will show you how to govern your entire stack with GitOps. For this first part, we have decided to use Kubernetes as the example infrastructure, which we will assume to be provided to us. There are, of course, many other examples which we could have used, like AWS Lambda or any infrastructure platform given to you by a provider. Now, before we can deploy our microservice to an environment, we obviously need to build it. This is usually done with a continuous build pipeline, which runs based on code being pushed to our microservices Git repo. In this pipeline, we ideally lint our microservices code. We run unit tests on the code, and we test that our microservice behaves as expected in a mocked environment by also performing some component tests. Strictly speaking, these tests have nothing to do with GitOps, but they're very important for us for building our confidence that our microservice will behave in the way we expect it to behave when it's deployed automatically later. So let's assume that all of these steps have completed successfully in our pipeline. At this point, the actual build step is executed. The build step packages our microservice into an artifact which contains all of the things needed for our microservice to run. In our running example, we're obviously thinking of a container image, but there are other formats like VMs built with Packer or jar files or tarballs, depending on what your target platform looks like. The important thing is that the build pipeline produces one artifact, which is independent of the potentially many target environments to which this artifact will be deployed. We want to build an artifact once and potentially deploy it many times. So with our continuous build pipeline happily churning out artifacts based on commits on the source code, we need a second and separate step for marking certain instances of those artifacts as releases. This usually happens in a second pipeline, which detects Git tags being created in our microservices repository, and which adds this tag to the metadata of the corresponding artifact. In our running example, this would mean tagging the container image with the version in the Git tag. The second step of the release pipeline uploads the tagged artifact to a central store, where this version of the artifact can later be referenced and pulled during deployment. Obviously, again, in our running example, we're thinking of an image registry here, which will then be referenced from Kubernetes YAML files when deploying our microservice together with other microservices. However, depending on your target platform, you might be using a different type of store in this case, like an S3 bucket or a Maven repository. In any case, it will be something that can hold built artifacts in different versions and serve particular versions of artifacts on demand. So with our built and released artifacts nicely stored by version in a central store, we're now ready to do actual GitOps. This is where the topics of our previous two episodes come in handy. Namely, we put a pipeline in place which applies a declarative representation of our microservice architecture stored in a Git repository. Whenever we update our declarative representation, say, for example, to make a config change, but also to introduce a new version of some microservice, then we do this via the Git repository, and our pipeline will take care of the deployment step. Because we're using a declarative approach, our pipeline doesn't need to know the procedural details of how to deploy our application. It just idempotently applies the representation and relies on the underlying technology to figure out the steps needed to reach the desired state. In our example, the declarative representation are the Kubernetes YAML files containing deployments which reference container images. The pipeline itself is implemented in Argo CD because Argo is the most straightforward Kubernetes native option. But again, depending on your target platform, you would be using different technologies like, for example, GitLab CI or Circle CI to run your pipeline. But what if we need to deploy to several environments? Maybe our team needs to perform some integration testing of new versions of the microservice architecture before deploying the whole thing to the production environment. This is not a problem for GitOps. In this case, we would keep a declarative representation of our microservice architecture per target environment and create one deployment pipeline for each target environment, which monitors the corresponding representation. In our Kubernetes example, you will see how we use customize in order to manage the differences between two environments without having to repeat ourselves, while at the same time staying declarative. So coming back to the integration test scenario, in this case, we would push the representation of the int environment to our Git repo, pinning the red microservice, in this case, to a new release candidate version, say 2.1.1 RC, and thus triggering its deployment. We would then perform our integration tests, and let's assume that these succeed. We would then retag our red microservice artifact to make it a proper release 2.1.1. Finally, we would push the representation of the prod environment to our Git repo, pinning the version of the red microservice to 2.1.1, and thus triggering the deployment of the prod environment. So we have now discussed all of the steps leading up to a deployment in GitOps. So we're now ready to have a look at how this works in practice. We're going to use a very simple but very awesome application on Kubernetes, and we're going to see how it is managed using Argo CD. So the first thing I want to show you is Argo CD running in my cluster. So as you can see, here we have an instance of Argo CD. This is actually running on top of my Kubernetes cluster. And currently, Argo CD is managing two environments, two application environments. One we call prod and one we call int. So if we go to the prod environment here in Argo CD, you can see that an application is already deployed in the prod environment. It's the awesome application that I was talking about. And you can see that it consists of one deployment, which in this case is using 3 replicas to guarantee downtime-free upgrades. So if we go to our source code repository, you can see that, sorry. if we go to our source code repository, sorry, I need to quickly change. Yes. We can see that I have two YAML files, one for each environment that I showed you in Argo CD. And basically, these are the definitions that we need to feed to Argo CD in order to get those two environments up and running that we saw. So if we have a look at the int environment YAML file, then we see how this is structured. So this is of kind application. This is a kind that's introduced to the cluster by Argo CD. And as you can see, each application in Argo CD has a source. And basically the source specifies the Git repo, which Argo CD uses to control this environment. So you have a repo URL pointing to our Git repo. We can specify a target revision, which in this case is just head. And we can specify a path for Argo CD to look for Kubernetes deployment or Kubernetes YAML files which define our desired state. In this case, we're pointing to a customization. Specifically, we're pointing to the customization of the int environment. On the other hand, Argo expects a destination in this application YAML, and the destination is telling Argo where to deploy to. In this case, we're deploying to the local cluster where Argo lives itself. So this is a sort of canonical name here that we use. And we have to specify the namespace. So in this case, we're using awesome GitOps int, which will be the namespace for our int environment. Then down here, we can specify the sync policy. And the sync policy basically defines how strict Argo runs its GitOps process. So we have specified prune to be true, and specifying prune to be true causes Argo to basically delete anything which does not have a representation in the Git repo. So if I were to manually create some resources in the namespace awesome GitOps int, then Argo would detect this and would actually see that these resources, these manually created resources, are not reflected in Git and would delete them again. And then there's a self-heal option, which we also set to true. That enforces basically Argo to basically override any manual change that I make to resources which are specified in Git. So if I were to, and I can actually show you this later, but if I were to, for example, change the number of replicas of my deployment manually on the command line, then Argo would again correct this by reapplying the state from Git and overriding my manual changes. So that's the int environment. And I can quickly show you the prod environment just so you can see what changes when we go to prod. So basically, we're using the same source repo, obviously, but we're using a different customization path. So I have two environments coded in one Git repo using customize. And obviously also the target is a different one. In this case, it's the productive namespace of our on our cluster. So I can also quickly show you the environments. So if I look at the int environment customization, it's currently pinned to the version 2.0 of the awesome image that I'm using. whereas the prod environment is currently pinned to the version 1.0 of that same image. We can quickly have a look at the image in Docker Hub. So this would be basically the image registry that we're using and that we're referencing from our Kubernetes YAML files, where basically our build pipeline produces its new images. And indeed, you can see the awesome image has a 1.0 version and a 2.0 version here. And if we check our actual environments, so the prod environment here is currently on the version 1.0, whereas the int environment is already on the very awesome version 2.0. So obviously ahead because our developers have worked ahead. Right, so now if I were to first make a change manually in my prod environment, let me see what happens in this. Let me show you what happens in this case. So I can quickly look at my pods in my namespace. I'm in the correct namespace, yes. So if I were to edit this deployment, so I'm a naughty engineer who's going to edit the deployment by hand, even though it's managed by Argo CD. As you see, I tried to reduce the number of replicas, but unsuccessfully, as we see, because Argo CD already detected that I did this and reapplied the desired state from Git. As you can see, 2 of my 3 replicas have been restarted very recently. That was due to the fact that Argo restarted them when I killed the 2 replicas by manually editing. So that's the self-heal option that you see is currently in effect. And now I want to show you how we would upgrade our prod environment to the version 2.0 using GitOps. So in this case, that means we have to look at the productive environment's customization. And here I want to specify a new version, namely the version 2.0. And let me also specify here some, or reset, give new values to some of these variables. So something even more awesome. And let's quickly correct this as well. So we have made our change to our customization. So I can see the diff that I'm about to apply. I can commit that. We obviously need to give a very good commit message here. And if I push that, then we can check that Argo now picks up this change. So now looking at the production environment, we should very soon see Argo reacting to our change. I can speed this up a bit by hitting this refresh button up here, which basically just causes Argo to do that check a bit quicker. And as you can see, Argo has detected this change in Git and is now doing a nice rolling upgrade of my application, my productive environment. And indeed, if we go to check our productive environment, we see that the rollout has been successful. So that brings us to the end of this demo and also of the first part on GitOps for applications. And I will now hand over to Lena, who will show you how to extend GitOps to your infrastructure stack.
Yes, thank you, Tis. Let me also share my screen. Can you all see the presentation?
Yes.
Can you see the first slide already? Yes? Okay, great. So far we have only talked about applications, but what if your team also manages the infrastructure layer, or you are actually the platform team? Excuse me. Then GitOps goes a lot further. Sometimes the distinction between applications and infrastructure is not clear cut. One example of that are custom VM images that might contain your applications. There it's not so clear excuse me, whether the creation and hosting of these images should be done by the application team or by the infrastructure team. But however, as you will see, most of the concepts and workflows, they are very similar between the application and infrastructure code. And for this webinar, we have decided to use Terraform as the running example for the declarative infrastructure. But there are, of course, many other examples like AWS CloudFormation or Ansible Tower or others. Obviously, there are many ways of how to structure your different components, teams, and also your Git repositories. One form, sorry, we see a lot, excuse me, is to have the application-specific infrastructure with the applications themselves. So as you can see, we have an infrastructure directory in each of the applications Git repositories that contains the respective Terraform or just the general infrastructure code for the application. So in here, there are all of the dependencies of the application, like databases or message queues, for example. And by doing so, we can release the application as a whole, including all of its runtime and all of its dependencies. And all that is separate at this point is the respective configuration of the apps, because that is environment specific. Sorry, and because of that, we have a repo that consolidates each environment. And that you can see here on the right-hand side. It instantiates each component from the left-hand side and configures and parameterizes it for the respective environment. For example, here we have a production.terraform file and a development.terraform file. And these contain all of the components from the left-hand side configured for the respective environment. So for example, in production TF, we might have a full-blown server that is quite beefy. And in development, we might have fewer resources. We might even disable encryption to save some costs. Or we might enable some debugging options, stuff like that. And that is also where the releasing of the apps sorry, comes in. So from these applications, as we saw before from these, we build and release the application itself, and we release it containing all of the infrastructure code that is necessary for it to run in an isolated way. And then we release that together. And in the environments, we then reference this release version and then do the deployment from here. So we would do a Terraform apply from this repository to the respective environments. And this obviously would be triggered by us changing the reference to the respective version of the module over here in the development TF or the production TF. So let's have a closer look at that. Firstly, we want to look at the build step of your infrastructure modules. And just like for the application code, it makes sense to separate the build, the release, and the deploy phases. For Terraform, the term build might be a bit confusing because the code doesn't actually need to be built. However, it still makes sense to validate and prepare your commits to be released. So maybe prepare would be a better name in this case. And since infrastructure code is mostly quite heavy to test and deploy, it is important that we can detect problems as early as possible here. A comprehensive build pipeline that performs sanity checks on your code is therefore crucial. As with any pipeline, it makes sense to run the faster and more lightweight tasks first so that we can fail fast if something is wrong. Terraform, for example, offers a validity check feature that checks for syntax errors in your code and fails if there are any. Similar to that, we can very quickly check if the code is formatted correctly according to the Terraform community best practices. So as you can see here in the example, Terraform validates the code itself, whether there are any syntax errors. And then Terraform funct checks for formatting errors in the code. And Terraform funct, I think, was borrowed from GoFunct, which is a tool to actually create the respective formatting, but it can also check and verify it. That is a built-in command in the Terraform CLI, as you can see. The next step after a simple sanity check is to perform some linting. Popular tools here are tflint and tfsec, as introduced in episode 2. tflint is a general linter, whereas tfsec focuses on security issues, as the name implies. Both can be customized and they can bring great value to help you and your team follow best practices around Terraform and detecting potential issues early on. So we can do all of this just by static analysis without having to deploy any infrastructure, without having to tear or bring up any servers that would result into costs or anything like that. And the last step that we can do before actually releasing new versions of our infrastructure modules is to run some isolated tests. TerraTest is a great tool to perform such tests. We introduced it in episode 2. It helps you to instantiate any module in isolation, run tests on it, like, for example, making HTTP requests or checking whether certain parameters have been set correctly, and so on. Afterwards, it tears down your whole deployment again. So it deploys one module, runs those tests, and then tears down that module again. This has the two advantages of firstly making sure that your module is able to run in isolation and that it has a well-defined interface to other modules. And the second one is it gives you some confidence when releasing because you know that the module as a whole is valid, is checked, and that it can run by itself without any errors. Then finally, in the case of Terraform, uploading our build to an artifact store is redundant, as the Git repository itself and its tags kind of represent the module itself and the version. Releasing your infrastructure modules works in a very similar way, as you would do it for applications, as Thies has shown before. Each module is released individually, and this happens, for example, by adding a Git tag that specifies a commit that we would like to release as a release candidate version. So you can see that here, Git tag, and then we have this little RC suffix to mark that this is only a release candidate and not a full release yet. Our automation pipeline then picks it up and runs a suite of integration tests on our infrastructure, including the newly created release candidate. This is represented here by this make integration test command. This can happen again by using TerraTest, which in this case could instantiate not just the one module, but a whole environment separately, and then run a couple of smoke tests on that ephemeral environment, and then tear it back down again. As soon as we are happy, we then create an integration tested release by adding another Git tag without the RC suffix. So that's what you can see here on the last line. This marks the final release, which in Terraform's case doesn't have to be uploaded anywhere, again, because the repository itself contains the artifact, which is just our declarative definitions of the infrastructure modules and resources. Now we are ready to deploy the newly released infrastructure module. Deploying happens, as talked about before, from a central repository, which keeps track of which version of which module is deployed where. So the deployment gets triggered by us changing the version of a specific module, for example, in this production TF file. When we then commit and push that change, the deployment pipeline will pick that up and make the necessary changes via Terraform in the respective environment. Let's do a quick demo and see how that looks in practice. So I prepared a little code example called TF demo. And as you can see, it contains the 3 Git repositories, my backend, my frontend, and my environment, which are corresponding to the ones that we have seen here. So they represent these 3 Git repositories. First, we can have a look at the My Backend module. And if we have a look at the code, then we can see that this is just a normal Node.js application, which contains the before mentioned infrastructure subfolder. This one has 2 modules. One is the backend itself. And as you can see, this instantiates multiple things via Terraform. It works on AWS in this case, so it instantiates an AWS API gateway endpoint, a database, some DNS stuff, a Lambda function itself, and it does some stuff with the networking and so on. So this is all of the necessary infrastructure that we need for our backend to run. It's all of the firewalling, all of the networking, and the respective runtime as a compute instance, in this case, Lambda. Also, we see that it contains another module, which is the DB. And this just tells us how to instantiate the database itself. Now, this is instantiated in turn by the backend module, as you can see here. So the DB itself, this file, it just instantiates the DB module and parameterizes it in a specific way. By doing so, we can make sure that our backend as a whole is represented as a Terraform module, but also the database that it consumes is a separate Terraform module, which then gets instantiated by the backend. If we then have a look at the environment repository, this has files for the development environment, here prefixed with dev, and it also has files for the production environment. What it also contains are some of these global ones, which there are sometimes resources that we want to share across environments that just allow us to facilitate everything. In this case, for example, we have a global monitoring setup that we in turn have written as a Terraform module right here. But this is global, so it spans across all of our environments. The environments themselves, they consist, as said before, by instantiating backend. So as you can see, this just instantiates the backend module that we have defined before, and it parameterizes it a bit. For example, it gives it the environment name of development, it gives it some secrets that are maybe different from dev to prod, and so on. And if we look at prod, then we again have a backend module that, as you can see, also again instantiates the module. The main difference here is that dev module of the backend, as you can see, the source, it just references the latest version of our backend module. So it will always instantiate the latest commit. And that's kind of what we want in our development environment. In production, however, we want to have the nicely released versions that Thies showed before. So what you can see here is that we reference the module at a specific version. And this version then references to the infrastructure configuration of the backend module at this point in time, but also the application as a whole. And if we go look at the backend module again, and have a look at the Git commit history, then we can see that we have this one tag here that contains some further changes, and that is currently also the latest version. But we could then, as Thies showed before, increase this tag to a new Git commit and then change the respective reference in the environments folder, and that would then trigger another deployment. Another specialty here is if we look at the front-end code, and here we don't have an infrastructure module, an infrastructure directory. And that is because our front-end is just a simple single-page application. So it is very generic to deploy. On AWS, we just put it into an S3 bucket, put a CloudFront distribution in front of it, and that's it. And since this is so generic, if we look at how the front-end is instantiated, we can see that this uses public GitHub or a public Terraform module hosted on GitHub. So this is how we can also include third-party stuff if the things that we do are so generic that we don't have to write our own infrastructure modules, but we can consume them from third-party providers, like, for example, HashiCorp themselves, or that other people have written. Now that we have seen the basics of doing GitOps with applications and with infrastructure, let's have a look at some advanced concepts. GitOps itself is a very interesting concept that can bring great value and stability to your projects, but these advanced concepts allow you to explore it a bit more and see if you can find some ideas that you can follow once you have achieved stable GitOps workflows. So far, we have only been talking about deploying specifically tagged or otherwise marked releases. However, there is another interesting concept around GitOps, which is called continuous deployment. And in our view, true continuous deployment means that every commit to a branch is directly deployed into one or multiple environments. And yes, that sometimes means even production environments. For example, my team could have a single main branch with my application repository, and all of the changes to this main branch go directly to production. So there is no specific versioning or tagging or releasing. Me and my team are confident that any change that we make is safe and good to go to production. Now, obviously, it takes either a great ego or some serious testing courage to get to that confidence level of releasing everything into prod. Good test coverage on a unit, an integration, and an end-to-end level is crucial to releasing this often. Another important point to consider is that we might have features which are on our main branch, but which we don't want our end users to see yet. For that, feature flags can be very helpful. In the simplest case, this means that we have an if statement in our code that checks if a specific feature has been enabled in that environment. For example, just by simply setting an environment variable. And only if that environment variable is enabled, this feature flag will be displayed. This feature will be displayed. And by doing so, we can control the features and their availability in the different environments independently from the code releases. We do that via configuration, as an example, via environment variables. At this time, many people do true continuous deployment, but only in non-productive environments. So, for example, in dev or staging. It takes a lot of maturity and courage to move this process to a productive environment. But we can only encourage you to do so, or at least to strive to do so, because it brings many advantages The best one being that it actually forces you to have such a good test coverage and such a good confidence in your code. Another concept that is fun and has become kind of a buzzword is GitOps. It means that we can trigger certain steps of our automation pipelines by using our normal communication tools. So for example, we could have a Slack or Rocket Chat instance that we also use for our usual team communications. And in there, we could have a deployment channel. In this channel, people simply have to type deploy production, for example, as a chat message. And our automation server listens on that chat channel for certain messages. And as soon as they get posted, it does its thing. So for example, then it starts the actual deployment. This is not as thoroughly automated as pure GitOps because there's the manual step of writing a chat message and sending it. However, a combination of GitOps and ChatOps can be quite interesting. For example, the deployment into development and staging environments could happen fully automated via GitOps, and there is no manual intervention or user interaction needed. And then for the deployment into production, we want to be a bit more cautious and only trigger the deployment after we have done thorough manual testing. This means that we can do this testing and only after everybody is happy and the release manager has signed off the release, then we trigger the deployment via a chat message. This still has many of the advantages of normal GitOps, namely that anybody can trigger releases and the process of deployment is documented and automated still. Lastly, we quickly want to look into security, because GitOps brings great benefits in terms of security. By tracking all of the changes to our applications, but also our infrastructure in Git, you get a clear audit trail of what was done when and by whom. To get this benefit, it is crucial to only accept signed commits to ensure that the person who claims to have made a commit actually did. This can be done by a GPT and is supported by most Git servers these days, like GitHub, GitLab, or Bitbucket. Another benefit in terms of security is that you get to lint and code review all of your code and do pull requests. Therefore, this ensures that you follow best practices and that you don't have any security holes that could have been detected easily by simply doing static code analysis or by your colleagues looking over the code. All of the changes go through the team and are rolled out in a structured way. Furthermore, GitOps always gives you an up-to-date summary of what is deployed where and how your infrastructure and applications are configured. This is great for manual security audits and simply to review your code as a team from time to time, which can in turn allow you to find security holes or to find places where you could improve. Thank you very much to everyone for attending this webinar series. We highly appreciate your participation, and we are looking forward to meeting you again at other meetups or webinars. As a last important takeaway, please be aware that different teams might be at different maturity levels when it comes to GitOps. Usually, application teams are rather quick at adopting such deployment and lifecycle strategies, so it's possible that your apps are already deployed using GitOps, but your infrastructure, on the other hand, is still maintained in a traditional way, for example, using a GUI and clicking around. And this gap can be very dangerous because the infrastructure might not be able to keep up with the fast pace of change that GitOps allows the application teams to follow. So therefore, it is important to be aware of this gap and communicate well among the different teams and components that make up your environments. That was it. Thanks again for listening and for being there. Adrian, I think we cannot hear you.
Oh, indeed.
No. Oh, sorry. I thought the problem was on my side, but
No, indeed, my microphone was muted.
Shit, same here. Sorry, I thought it was just me.
No, it's okay. Thanks for letting me know. So what I was saying is, thank you so much, everybody, for attending this webinar. Thanks, Lena, and thanks, Mathis, for the great content. And thanks to all of you who have been following the 3 installments of this series. And of course, in the future, new episodes might come. If you have any questions, there's a Q&A box on this Zoom call. Maybe you have some doubts, something you would like to ask the participants. Please go on. I will wait for a few seconds to see if somebody writes something. But I think there are no questions in any case. The Q&A box was open all the time anyway. So I would like to thank everybody. Thanks, Lena and Mathis, as well, for, in particular, for the great content. And yeah, you've got the links to the previous 2 episodes, episode 1 and episode 2. Check them out. They are all on YouTube. And stay tuned for more webinars about cloud native technologies. Thank you so much. See you soon. Bye-bye.